You've probably heard of the term flattening the curve. But what is this curve? And is it good if we flatten it? Let's bring some basic math to explain what flattening the curve means. Here, I have a graph showing the number of cases on the vertical axis and the time since the first case on the x-axis. To put it simply, this is the curve that the term refers to. As you can see, it's not very flat. As such, this actually represents the case if we take no action to the coronavirus. No social distancing, no quarantine, no masks. As you can see, it goes above the hospital capacity by a major amount. This means hospitals are unable to deal with the massive surge of patients and therefore are undersupplied to deal with the pandemic. We have seen and continue to see this in countries like the US and Italy, who were slow to put social distancing and quarantine. However, if we take the second line, which looks much flatter compared to the first one, this shows a case where measures are taken from an early date, causing the daily infections to grow slower, and it forces the number of patients to stay under the hospital capacity. This allows hospitals to deal with the pandemic in a better manner than the first case. This has occurred in countries like South Korea and Japan, where social distancing and quarantine were implemented quickly near the start of the outbreak. So far, we've seen graphs which have the daily infections on the y-axis. But what if we were to change this and still make it look the same? What if we were to bring in cumulative infections and put that on the y-axis instead? Would we still see the concept of flattening the curve there? But to understand how a cumulative graph would look, we first need to understand the concept of an exponential curve. This is the curve and it shows y is equal to 2 to the power x, and it represents approximately as to how the virus will spread. As a replacement for the exponential model, we instead use the logistic model. The equation was thought of and founded by these guys. Here's the logistic model, both in graphical and in equation form. As you can see, when x is pretty low, the logistic model increases in similar fashion to an exponential function. However, as x goes on and y approaches the dashed line, the curve's growth begins to slow down. Some of you calculus geeks may have actually noticed that this is the antiderivative for the graphs shown at the beginning of the video. In the context of COVID, we can see through both cases that as the time goes on, the curve begins to flatten. And through this example, we can see that flattening the curve really means that the amount of new people being infected each day decreases. By understanding the term flattening the curve, you can help the world solve the pandemic.